The PM2 criterion is applied when a variant is absent or extremely rare in population databases. In the last video, I explained what it means for a variant to be rare and how to think about rarity thresholds for each disease. Today, I'm going to talk about a second key aspect of the PM2 criterion, which is understanding what the general population actually is. Welcome to the Reclassifica channel. My name is Renata, I'm a geneticist, and I work professionally with genetic variant analysis and classification. I created this channel for professionals who want to learn more about genetic variant classification. Classifying a genetic variant means looking for evidence that will ultimately tell me the probability of that DNA change causing a disease or not. One of these pieces of evidence is precisely the rarity or absence of this variant in population databases. But to really understand this evidence, it's not enough to just know if the variant is rare. We also need to understand who is represented in the general population. And that's what I'm going to explain to you today. In an ideal world, we would have the genetic sequencing of everyone in the entire world to understand the genetic variability of the population. But since that's not feasible, we use samples, TNOs, population groups intended to represent the general population with all the flaws, limitations, and biases that any sample has. The main population database we use to classify genetic variants is called gnomAD, which is short for Genome Aggregation Database. gnomAD aggregates genetic data from thousands of people from different ancestral groups and shows the frequency of variants in those individuals. Version 4, which is the latest version of gnomAD, features samples from 807,162 people, consisting of 730,000 exomes and 76,000 genomes. This data comes from several different sources, but mainly two: the UK Biobank, which is a prospective cohort from the United Kingdom, and also other large studies, over 100 studies from at least 25 countries. A very important point to understand about gnomAD is to always remember that it has a deeply European bias. So gnomAD doesn't represent all ancestral groups equally, because a large portion of the data comes precisely from the UK Biobank, which is a European cohort. So in practice, when we're analyzing gnomAD version 4 data, 77% of the samples are from people of European ancestry, and all other groups are underrepresented. Another essential point to understand about gnomAD is to always remember that it is not a database of healthy people. Quite the contrary, the gnomAD group itself gathered important information about the studies that made up the gnomAD database. And now in version 4, they've published this table on their website showing some of the studies that were conducted and whose samples were included in gnomAD. So look, here for example, we have studies on Alzheimer's disease and we have case control studies, which means there are cases, people who have the disease, and controls, people who don't have the disease. And in the group, in the gnomAD databases, both cases and controls were included. The same goes for the other conditions listed here, so atrial fibrillation, bipolar disorder, cardiac arrhythmia, type 2 diabetes, etc. So the most accurate way to think of gnomAD is as a reference population database, but by no means a group of healthy people. It's very important to keep that in mind. When we open a variant page in gnomAD, here in the upper right corner, we can access some subgroups of this large group that gnomAD contains. So here in the upper right corner, we have, for example, the option to access only gnomAD v4 data, version 4 of gnomAD, that did not include people from the UK Biobank. In version 3, we can access the non-neuro group, for example, which includes those samples that were not recruited from cases in psychiatric or neurological studies. So those patients who are cases of Alzheimer's disease were probably removed from this non-neuro gnomAD v3 subset. One of the great lessons that gnomAD has taught us is that it's normal to have genetic variants. So everyone has some variants compared to the reference genome. And these variants are of many different types. So on the gnomAD statistics page itself, they show the variants that were found in the general population in this version 4. And there you can see that there are SNVs, there are indels, there are structural variants, we have nonsense variants, frameshift variants. This is the group, the type of variant that always catches our attention when we're looking for the cause of a specific genetic condition, because they usually lead to a loss of protein function and are typically poorly tolerated. As we can see here, there are many variants of these types in the general population as well. Furthermore, most of the variants that appear are rare. More than half of them appeared only once in gnomAD. So not only is it common to have genetic variants, but it's also common to have rare genetic variants. That's why it's so controversial to say that being absent from population databases indicates pathogenicity. Another important point is the age of the people who make up gnomAD. Although people over 50 of a slightly more advanced age do predominate, 2.5% of the people in version 4 are under 40 years old. So think now, if you're analyzing a genetic variant for a specific disease like Alzheimer's disease, which usually presents symptoms after age 45, if you found 10 people in the general population who have this variant, that might not mean anything if those 10 people are between 30 and 40 years old. That's why it's super important, super interesting for you to always look on the gnomAD variant page for the age distribution of the people who have that variant. And we can do that on the variant page itself. So if we go down a little bit, there will be this table that will show exactly the distribution of the people who have the variant. So I always uncheck this to compare with all individuals to make the image cleaner. And then when you hover your mouse over it, you can see the age of the people who had that specific variant by age group. Well, what about the Brazilian population? So the truth is that Brazil is very poorly represented in gnomAD. Generally, we consider the Brazilian population to be part of this subgroup called admixed American, mainly as Latinos who make up the admixed Americans. But Latinos represent only 8% of admixed Americans. So admixed Americans are already underrepresented within the gnomAD group. Latinos, which actually doesn't just include Brazilians, it certainly includes few Brazilians, represent a small part of admixed Americans. So everything we have in gnomAD definitely poorly represents the Brazilian population. It's always important to check the genetic information we have available for the Brazilian population. So today we have ABR-AOM, which we can access directly from the Franklin page as I showed you in the last video. And we also have the DNA do Brasil project, which is actually larger than ABR-AOM in terms of sample size and is still collecting, where they also provide information on the Brazilian population. It hasn't been incorporated into Franklin yet, but I'll leave the link here in the video description for DNA do Brasil, ABR-AOM, and Franklin. So to sum up, when we use the PM2 criterion, we need to understand what is rare for that condition, but we also need to understand the characteristics of the general population to really see what that allele being found or absent in population databases means. If it's a Brazilian patient, always remember that Brazilians are underrepresented in gnomAD and that we should also check the ABR-AOM and DNA do Brasil databases. In the next video, I'll talk about the benignity criteria applied when a variant is too common to cause disease, which are the BS1 and BA1 criteria. If you've made it this far, it's because this topic interests you, because you like this video. I'm going to ask you to subscribe to the channel. I've been posting one video a week. Leave any suggestions you have in the comments, and thank you so much to everyone who made it this far.